Hey everybody, this is Larry. This is me going Q2 of the bi-weekly contest 168, maximize sum of squares of digits. Hit the like button and subscribe and join me in Discord. Let me know what you think about this one. So the square thing is the first thing to realize. Honestly, I didn't even realize this much, but nums and sum is pretty big. My first idea was going to maybe actually think about dynamic programming, but as soon as I saw num and sum is that big, I was like, okay, maybe we have to do a little bit better. Because it was going to be like num times sum maybe and times another loop, so it was going to be too slow. Okay, the second thing to notice is that we have this function where you have to maximize the square, and the thing about the square is, spoiler alert, don't look at it. The thing about a square thing is that, well, you can just think it out, right? It is a function in which greedy operates. Because basically, if you think about it, you have 9 square, maybe plus 0 square, you can say. And then you have something maybe like 6 square plus 3 square. And this is 81, of course. And this is 36 plus 9, which is 45, right? And you can kind of, there are a number of ways you can kind of reason this out. For me, it is honestly pure experience because I've done enough, this is what I mean by practice, right? You just know how that square curve looks, and you know that it is going to be greedy in this way, and then you kind of like induction your way to all the other digits. But of course, you can also do it another way in which you just kind of, enumerate all the possibilities, and then notice the pattern that you always want 9s, and that's kind of the key part to it, right? And as soon as you notice that, then it just becomes okay. Then we want as many 9s as possible because we want the maximum number, and because we want the maximum score, but we want to also get the maximum good integer or whatever they call it. And of course, having that, you just want all the 9s in the front, right? Pretty straightforward. Yep, 9s in the front just gives you a bigger number. It's very intuitive. I hope I don't have to do a proof on that one. But in any case, so then it just becomes, okay, we have all these 9s, or as many 9s as we can fit, and then we have some digits left in which we just take the maximum. It's a very intuitive process in which I still got a wrong answer because honestly, this is the code. We'll go over the code and I'll go over a little bit of a retro afterwards. We'll do it this way. So here we have the number of 9s, and if the number of leftovers is greater than 0, then we just add that into the number. Remember, this is required, right? Because also, if you think about it, you cannot get fewer digits than this, right? Because, that's just how multiplication and division and all these things work. So if you already have too many digits, then you cannot go smaller, so you return an empty string. Okay. Otherwise, we pad everything with 0 and we are Gucci, right? Because you just need to add zeros to the end so that you have enough digits. And that's basically it. Honestly, for me, for this problem, maybe I blame a little bit on being tired, etc. But I kind of rushed a little bit because it was Q2. As I said in the contest, I just did not respect this problem's difficulty, and I got a wrong answer for it. And the wrong answer is maybe also I was just trying to both rush and be a little bit sloppy. I basically have this without the if statement. I wrote it in another way, but that's basically the idea. And as a result, when sum mod 9 is equal to 0, I add an extra 0 in certain cases. So that is my mistake. But otherwise, greedy is the idea, and this is kind of the reason why, if you really want a reason to think about it and think it through. It's not the proof per se, but yeah. Anyway, that's what I have with this one. Let me know what you think. This is O of 1-ish. It's not quite O of 1. It's technically O of n, where n is not, by the way, num or sum. It is the number of bits representing num or sum, right? And we say the number of bits because technically there's a result. The output has also. Wait, is that true? Yeah. It's a very confusing analysis, actually. But you could say this is linear as a result because each num and sum are represented by log n number of bits, where let's just say x is equal to the number of bits. We have x number of characters in the output, which is the size of the output, right? So this is going to be linear time, linear space, except for that in that case, because you can always represent a string with just 256 characters. Okay, I know, at least in ANSI, right? I know that there's other stuff, but what I mean by that is that if you you have a fixed width string thing, then fixed width per character string, then that is going to be for each input bit, which is kind of base 2, but you multiply by a constant, which is base 2 over base 10, or log 2 over log 10, or the other way around, right? But you get the idea. So this is why this is actually a linear time, linear space algorithm. Anyway, that is all I have for this one. Let me know what you think. Thanks for watching. And you can watch me solve it live and make a mistake during the contest next. All right? That wasn't that bad. Honestly, it being a medium scared me a little bit, per se, but it wasn't that bad. All right, num and sum. And maybe there's a dim, so we could get some dim sum. All right. N is good if it has number of digits is exactly nums, and the sum of the digits is exactly sum. Where does the square come from? Oh, the score is this. Okay. It's probably just. I was gonna say DP, but I guess not. A lot of them are not possible though, so I think it's still maybe just DP. Right. The number of digits. Oh, I know the number of digits. What is it saying? I think this is just greedy, right? I mean, I don't even know what it's doing, but just looking at these examples, you just put all the 9s in the beginning, right? As much as you can, really. It's okay. So, how do I want to write it? Yeah, no, it's just sum 9, right? You have this plus some mod 9. So you this will give you a thing, right? So m is equal to this, say, and then if m is less than num, then we just keep on incrementing, right? Or add zeros. So delta m right? And then else, if m is greater than num, then we maybe I should have done that first, actually. Maybe that's cleaner. Then we return, because it's just not possible, because we already greeted it out. Otherwise, then we're good. And technically, I guess we don't even need the if statement, but length. And as we said, we don't need the if statement, though. I have to correct this part. 398, okay, YOLO submit. Maybe could have thought about it a little bit longer, but or just test basic cases. 9 is 1. If length right? Wait, why? Oh, this is just me being dumb, because this is okay, yeah, okay. If 9 is greater than 0, okay. Man, I rushed it for sure. There's nothing about it. Dumb. Let's try. I have to try something just in case. I don't know. Alright. that was just dumb. That's such an obvious case, but I didn't respect the Q2. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.